Okay, so I thought I would make a quick video, well, we'll see how quick it is, just sort of giving an overview of all the chapters and what I think is important from each one, or like what is a likely type of problem from each chapter. Um, and I don't want to claim that this is like fully exhaustive, but I've made some effort to include everything that I think is important here. Um, but yeah, I may have left off a couple of things. So of course, I encourage you to look over all the old quizzes and the test reviews and stuff. But I thought this might be helpful anyway. So from chapter one, I basically covered it in the last video. There's just four types of differential equations that you should be able to recognize, tell the difference between these types, and solve each one. Um, Chapter 2, there's not a whole lot from Chapter 2. There was like the population stuff, but the truth is, for these population models, you just set up a differential equation and you solve it. So if you're able to do that, you can do that. Maybe the more important thing from Chapter 2 is, if you remember, the stable versus unstable equilibrium. And this is back in the day when we weren't doing 2x2 systems. There was just one differential equation. And so you just draw this number line to determine whether it's stable or unstable. It was much easier. You didn't have to do the Jacobian and that business that we've been doing more recently. So that was in Chapter 2. Also, there was Euler's method in Chapter 2, but I'm not going to put an Euler's method question on the final. We had one on a quiz, so I'm satisfied with Euler's method. So there's not really too much out of Chapter 2, or what there is easy. Chapter 3 is important, but it's also skills that we have used repeatedly later. So for example, in Chapter 3, we learned how to put a matrix in echelon form or reduced row echelon form, if we want to go that far. To solve a system of equations. Also, that was the chapter with matrix inverses and determinants, which I did a couple of examples of those yesterday. So inverses and determinants are important. Those are their own skill, and you should definitely know how to use those. This other stuff is also important, but it's also skills that we've been using in other things. So I'll get to that a bit later. So for that reason, maybe it's slightly less likely that I would specifically ask you a question about these, because you're going to have to use that skill anyway. I can ask you a more complicated question, and you'll have to know how to do this, whether I ask you a question specifically about this or not. Okay, so what about Chapter 4? Chapter 4 was it's like mostly a theory chapter, but like the theory of linear algebra. There's a couple of important types of questions I could ask you. We had a quiz like this one where I give you a set of vectors and I ask you, is that set of vectors linearly independent or dependent? And of course, you know the follow-up question to that is, if the answer is linearly dependent, then you should find a non-trivial linear combination of these vectors to equal the zero vector. We had a quiz like that, and maybe there was a question like that on test 2. I don't remember. I could also ask you to find a basis for a solution space to some matrix equation. Then in Chapter 5, this is the chapter where we solved, it was those higher order linear differential equations with constant coefficients, like this. And by the way, don't actually attempt this example. It's probably not very nice. I wasn't very careful how I chose these coefficients. Most likely, if if you really attempt this example, the polynomial is not going to factor nicely. Like you get r cubed minus 2r squared plus 3r plus 2, and then you try to factor it. I don't think that has any nice roots. So, but I wrote this example just to remind you of what these look like. This is it's a higher order. It's an order 3 differential equation, constant coefficients. This is a non-homogeneous one because I don't have 0 on this side. You should know how to handle non-homogeneous ones. But yeah, this is hopefully this rings a bell. These are those problems. These are the ones where you write down the characteristic equation. You go directly from this to writing r cubed minus 2r squared and so on. Chapter 6, we didn't, well, we only really covered section 6.1 just as an introduction to what eigenvalues and eigenvectors are. So from chapter 6, you should just be able to know, or to find eigenvalues and eigenvectors. And by the way, finding eigenvectors is an example of a question I could ask you where you would have to use the skills from chapter 3, because finding eigenvectors is really solving a system. If you remember, once you find the eigenvalues, the way you find the eigenvectors is you subtract the eigenvalue down the diagonal and you set that matrix equal to 0 and solve that. You're really just solving a system. So that's an example of how I could make you use the skills from chapter 3 even if I don't make a question that's all about that. Anyway, where were we? Maybe chapter 7. Chapter 7 is where we learned how to solve. This is getting into more recent stuff that was on the last test, actually. This was solving linear systems of differential equations using eigenvalues and eigenvectors. And, well, of course, that would be an example of how I could make you use the skills from chapter 6 without really going out of my way. If I ask you to do one of these, you have to use a bunch of skills. Like you have to use chapter 6 skills, which means you have to use chapter 3 skills. So there's a lot of these things that, yeah, once again, I may not ask you a single question that's specifically out of chapter 3, but you have to use those skills. Anyway, chapter 9. Chapter 9 was the stability, and now this is where we were talking about 2x2 systems. So this is, if you remember, just to jog your memory, this all boils down to the eigenvalues of the Jacobian matrix. In particular, you look at the real parts of the eigenvalues, because the eigenvalues might be complex, but you look at the real part, and you look at the real parts and look at whether they're positive or negative, and that tells you the answer. Chapter 10 was Laplace Transforms. We just did that. And chapter 11, which I covered very lightly, I put a couple of practice exercises from 11.1, but it was the power series stuff. Okay, so yeah, hopefully that's helpful. So I'll scan and upload this sheet that I made, and then maybe. So I haven't received any specific questions from anybody, which is fine. That just means I'll pick some random stuff that I think might be helpful. But please ask questions if you have them.